All right, U9D and E, check your understanding. So, vertex form of a quadratic equation. So we're going to cover an exception to what we did in the classroom work. On the back side of this, we'll do what we did in the classroom work. Okay. But on this side right here, we're going to look at what happens if I have a quadratic that is in this form. This is called the vertex form. We could certainly change it out of that into standard form, and things would work like everything else. Okay, but this is one that if you recognize it and you choose to do it this way, it might make more sense to you. It might just be more confusing. So we'll put it out there because you should have seen it at some point. You'll definitely will see it in Algebra 2. So the only time that this method works is when your equation is in this vertex form. So we get the vertex form set equal to 0. The key thing here is that the variable shows up only one time in all of this thing. Okay? And so we can solve it a little bit more like we did linear equations. Most of the time, solving quadratics doesn't look anything like linear until we've maybe factored and got it down to 2 linear equations. So what we're going to do here, we've got this in vertex form, set equal to 0. So I'm going to subtract 8 from both sides. I'm going to multiply both sides by -3, so that'll cancel out the -1/3, and -8 times -3 is 24. And to get x minus 4 squared equals 24. This is then the new step. To get rid of the squared, I could do a square root. Okay. And when I do a square root, though, I need to introduce this plus or minus thing in there because I don't know if the number was supposed to be positive or negative. The square root almost gets rid of the squared, except that it does have to have this plus or minus that's in there as well. And then I'll just add 4 to both sides, and I get this one, this 4 plus or minus square root 24, which looks a lot like what I would have gotten if I'd done the quadratic formula where I calculated the discriminant, and it told me you've got 2 answers, but you can't factor to get them. Okay? So if we try that here a little bit, we'll add 49 to both sides, and I get x minus 6 squared equals 49. I'm ready now to get rid of this squared by doing the plus or minus square roots. In this case, I get x minus 6 is plus or minus, but the square root of 49 is 7. And so if I add 6 to both sides, it says I can have x is either 6 or is 6 plus or minus 7, which means x is either 6 plus 7 or x is 6 minus 7. 6 plus 7 is 13. 6 minus 7 is -1. So I get 2 answers here of x equals, clean that up a little bit, x equals 13 or x equals -1. Okay. So following the same thing, 2 times x minus 1 squared, add 6 to both sides is a 6. Divide by 2, x minus 1 squared is equal to 3. Do this square root business. I get x minus 1 is plus or minus square root of 3 is not a nice number. Add 1 to both sides. I shouldn't say that about numbers. I love all the numbers. 1 plus or minus square root 3. All I meant is it's not a rational number or an integer. It's what we call an irrational number. This is 2 answers. This is 1 plus the square root of 3. It's also 1 minus the square root of 3. That's what that symbol means, so that I can write my answers a little more compactly. Okay, subtract 4 from both sides here. I get a negative. X plus 7 squared is equal to -16. So x plus 7 squared is equal to positive 16 if I multiply both sides by -1. Square root business. X plus 7 is plus or minus square root of 16 is 4. So that means x is going to be either -7, Or I could do it this way. I could say it's either going to be 4 minus 7 when I subtract that, or x is going to be negative 4 minus 7. 4 minus 7 is negative 3, or negative 4 minus 7 is x equals negative 11. Come on. Subtract 4 from both sides. Negative x plus 7 squared is equal to 16. Multiply by the negative, I get x plus 7 squared is negative 16. Square root business. And it's asking me to take the square root of a negative number. If I go to my calculator and try to do that, it's going to give me an error. You cannot take square roots of negative numbers. Okay? Which at that point, because you try to do that and it gives you an error, when you try to get to that point, that means that there are no solutions to this equation. This is an example of a parabola that would not intersect the x-axis. It would be, looks like probably all below the x-axis if I was guessing on that. It's not really a guess, I know. Okay? That has no solutions. Okay, this one, 6 times x plus 2 squared, subtract the 4's from both sides, and it says equals 0. Divide by 6, I still get x plus 2 squared equals 0. Take a square root on both sides. Square root of 0 is 0. Plus 0 minus 0 is all just 0, so this says x plus 2 is equal to 0. Subtracting 2 from both sides, I get that x is negative 2, and there is only one answer, which tells me my discriminant would have been 0 if I had worked that all out that way. And there would have only been one answer. All right. So that's that new stuff. This is, I would almost say, this is optional at this point. You never have to do this. We always have other techniques that we can use for this. Some people like it. Other people just want to stick to basically one process along the way. So, all right. On these, for each of these, use the discriminant. Okay, that's our b squared minus 4ac to decide whether you should use factoring or the quadratic formula, and then how many solutions you should get, and then find those solutions. Okay, so in this case, my a is 1, my b is negative 3, my c is negative 18. If I do b squared, negative 3 squared, this is my capital D calculation, negative 3 squared minus 4 times 1 times negative 18. I'm going to get a 9 here minus 72 minus negative 72, so plus 72, which is equal to 81. Positive number, so therefore there are two answers, two solutions, two x-intercepts. And square root of 81 is a nice number. This is 9 squared, and so I can factor. Okay. So set equal to 0, the x squared goes there, the minus 18 goes there. Numbers that multiply together to give me negative 18, but add to give me 6, or negative 3, sorry, I was thinking ahead. A 6 and a 3 makes an 18, and they're 3 apart, and if the 6 was negative, that would make that happen, so negative 6x and 3x, x minus 6 plus 3. So this problem becomes x minus 6 times x plus 3 equals 0. And I can apply the zero product property and say that x minus 6 is equal to 0, or x plus 3 is equal to 0. So x is equal to 6, or x is equal to negative 3. Those are the two solutions that I was looking for. All right, here I've got A is 2, B is 9, C is 4. So my capital D is B squared, or 9 squared minus 4 times 2 times 4. That's an 81 minus 32. 81 minus 32, because it's getting to be a long day. 81 minus 32 is 49, which is a nice number, so 2 solutions, and I can factor, because that's 7 squared. So we'll go with the 2x squared, the 4 there, multiply numbers that give me 8, and when I add them they give me 9. Sounds like an 8 and a 1. So an 8x and an x. 2x is a common factor there with the x, makes that a plus 1, makes that a plus 4. So this becomes an x plus 4 times 2x plus 1 equals 0. Zero product property tells me the x plus 4 is 0, or 2x plus 1 is equal to 0. This would make an x of negative 4, or 2x equals negative 1, and x is equal to negative 1/2. And those are the 2 answers that it was telling me about, the places where that parabola would cross the x-axis. All right. A is 1, B is 6, C is 10. Capital D is 6 squared minus 4 times A times C. So that's 36 minus 40, which is negative 4. So there are no solutions. I have no other work to do, because my D is negative. Okay, this does not say 0, so I can either move, I think I'm going to move these things over here and make it say 0 is equal to 3x squared. I'll subtract the 12x and subtract the 9. I like my A to be a positive number. It doesn't have to be, but I like it that way. I'm also noticing here that all of these things are divisible by 3. So I'm going to pull that greatest common factor out and look at x squared minus 4x minus 3. And feels factorable, but I'll go ahead and calculate my discriminant for these numbers in here. My b is a negative 4, so negative 4 squared minus 4 times 1 times negative 3. By pulling out the greatest common factor, all my numbers are smaller. So I get a 16 plus 12, which is 28, which tells me that no, that actually doesn't factor. When I do that, I do have 2 solutions, but I am going to need my quadratic formula. So it tells me that my answers, one of my answers, or if I want to combine them with a plus and minus, I can do that, is the opposite of b. My b value is negative 4. The opposite of that is positive 4. Plus or minus the square root of the d, which was 28, all over 2 times my a, which was a 1. So that is 2 answers there, and those are them. Okay, lots of stuff to do here. I'm going to add 2x squared to both sides. That's going to give me 2x squared plus 1x squared is 3x squared. I will subtract 7x from both sides. Negative 4 minus 7 is negative 11 x's. Brings that over. Subtract 2 from both sides makes a 0. So I get 3x squared minus 11x equals 0. I can pull a greatest common factor of x out of that. I get x times 3x minus 11 equals 0. And I've just created a product out of that. And so I can do my zero product property there. It tells me that either x is equal to 0 or 3x minus 11 is equal to 0. X equals 0 is x equals 0. This is 3x is 11, or x is 11/3. So my answers are either 0 or 11 over 3. Okay, final problem. All right, gonna have to multiply that stuff out. I'm gonna grab my scratch paper here, because I don't know that it'll all fit in here. So I'm gonna put a 3x plus 1 on one side, x plus 4 on the other, 3x squared plus x plus 12x plus 4 is 3x squared plus 13x's plus 4, and run a negative through there, so change the signs on all of them, negative 3x squared minus 13x minus 4. And so I'm going to take those things and add them back up here. I'm going to say this is negative 3x squared minus 13x minus 4. If all somebody looks at is the pictures of this, that's going to be a little trickier. And so I'm going to add 3x squared to both sides. That'll give me a 5x squared. Add 13x to both sides. That's going to be a plus 24x. Add 4. That's going to be a plus 16. Definitely going to be needing my calculator on this one, I believe. So my discriminant, now that I've moved all of that over to that side, that's equal to 0. And I know what my A, B, and C are. Right? A is 5. B is 24, C is 16. My discriminant is going to be 24 squared minus 4 times 5 times 16. 24 squared is, I should remember that one, but I don't. 24 squared is 576. 576 minus 20 times 16 is 320. 576 minus 320 feels like about a 256, which is 16 squared. So this is going to have two solutions, and I can factor. Now, even though I can factor, I'm going to show you that I wouldn't really have to either. I can still use my quadratic formula because I know that the square root of d part. So I would have, if I'm using the quadratic formula, I've got x is equal to the opposite of b, so there's negative 24 plus or minus the square root of d, which is the square root of 256, but I know that that's 16. All over 2 times a, 2 times 5. So this gives me two answers. One of them is negative 24 plus 16, all divided by 10, or x equals negative 24 minus 16, all divided by 10. Negative 24 plus 16 is negative 8 over 10, which reduces to negative 4/5. Or negative 24 minus 16 is negative 40 over 10, which is negative 4. So I have answers of negative 4/5 and negative 4. I could have gotten to that by factoring as well, but I can also use the quadratic formula. Right, because this is the square root of the 256 that I came up with for my d value. All right, and that is that. Unit 9, D and E, check your understanding. Remember, D was about actually finding those things, and E was about using the discriminant to help you determine what method it was that you were going to use to solve them.